You know, AI seems like it just exploded out of nowhere, right? One day we're talking about it, the next it's everywhere. But it's not magic. And the story behind it, well, it's this incredible, long, and very human journey. We're going to walk through that story together, and you'll see it's this amazing cycle of huge dreams, some really tough realities, and then these mind-blowing breakthroughs that changed absolutely everything. All right, so here's our roadmap. We'll start way back with the ancient dream of logic, jump to the official birth of AI in 1956, then get into the hype and the tough times, the AI winters. After that, we'll look at the big 2012 breakthrough that led to where we are now, explore the power and the paradoxes of today's AI, and finally, talk about the very real human cost of all this code. So let's dive into part one, the ancient dream of logic. You might think the story of AI starts with computers, right? With silicon chips and code. But nope, it actually starts with philosophy. Way, way before a single computer existed, you had thinkers just wrestling with this huge idea: what if you could map out the rules of human thought? Could you, in theory, automate it? And get this idea goes back way further than you'd probably guess. We're talking 1651. The philosopher Thomas Hobbes comes out with this quote: "By ratiocination, I mean computation." Basically, he was saying that reasoning, thinking, is just a form of calculating. That was a huge deal back then. It planted this tiny seed of an idea that maybe the mind isn't some mystical, unknowable thing. Maybe it's just a machine. And that seed grew over centuries, you know? It wasn't just one person. You had Aristotle, way back, formalizing how arguments work. Then Descartes comes along and says, hey, let's separate the mind from the body so we can study it. Leibniz dreamed of creating a whole formal language for thought. But the real game changer, the one that ties it all together, is the last one here, George Boole. In 1854, he created Boolean algebra, and what that did was turn logic into math, a system of true and false. And that, well, that's a language a machine could actually understand. Okay, so fast forward a bit. We've got centuries of philosophy in the bag. Now the 20th century rolls in, and it brings the machine. And in the summer of 1956, everything changes. All those abstract ideas finally found a home in a brand new field of science. It all happened at the Dartmouth Summer Research Project on artificial intelligence. A bunch of the brightest minds at the time, including John McCarthy, the guy who actually came up with the name artificial intelligence, they got together for this massive multi-week brainstorming session. And you have to understand, this wasn't just some boring conference. It was more like the Constitutional Convention for AI. This is where they wrote the rulebook and dreamed up the future. And just listen to the ambition in this one sentence from their proposal. They believed that every single aspect of intelligence could be described so precisely that a machine could be built to simulate it. I mean, think about that. That's not just confidence, that's boundless optimism. It basically became the mission statement for the entire field. For them, it was never a question of if we could do it, but simply how. This was the dream that kicked everything off. All right, part 3, hype, hubris, and the AI winter. Because, as you can probably guess, that incredible ambition ran headfirst into a wall of reality. And what started then was a cycle that would repeat itself for the next 50 years, a roller coaster of massive hype followed by some serious disappointment. And that period of disappointment has a name, an AI winter. And it's exactly what it sounds like. It's a cold, bleak time for researchers. The funding just evaporates, progress grinds to a halt, and suddenly AI isn't the cool new thing anymore. This has happened more than once, and it's always the hangover after a huge hype party. And the pattern is almost always the same. You can practically set your watch to it. First, you get these wild, exaggerated promises. Then reality hits. The tech just isn't there yet, and big projects fail. Then come the critical reports, basically saying this isn't working. And that's when the money disappears. Funding collapses, and the whole field just stagnates. The dream gets put on ice, sometimes for decades. So what was the problem? Why couldn't they deliver? Well, the roadblocks were pretty fundamental. For one, computers were just laughably slow by today's standards, not nearly powerful enough. 2, there was no big data. They had nothing to train these systems on. And 3, the algorithms themselves, while brilliant for their time, just couldn't handle the messiness of the real world. For the winter to finally end, something big, really big, had to change. And that brings us to 2012 and the big breakthrough. After a long, cold winter, a single event at a single competition changed everything. It was the thaw, the beginning of the AI spring that we're all living in right now. So you have to ask, right, what was so special about 2012? Why then and not, say, 1992? Well, it wasn't just one magic bullet. It was the perfect storm, the convergence of three huge things that finally came together at the right time. First ingredient, data. Just massive amounts of it. Specifically, a dataset called ImageNet. We're talking over 14 million images. And here's the key part. They were all carefully labeled by humans. This was the fuel. This was the food that these AI models had been starving for decades. Second ingredient, serious computing power. The hardware finally caught up. And funnily enough, we have the video game industry to thank. They created these things called GPUs, graphics processing units, for making games look amazing. But it turned out the way they process information in parallel was absolutely perfect for training AI. Suddenly, it was actually possible to crunch through that giant ImageNet dataset. And the final piece of the puzzle was the algorithm itself. A deep neural network called AlexNet. This was the recipe that brought the data and the compute together. AlexNet took the massive ImageNet dataset, ran it on those powerful GPUs, and entered an image recognition contest in 2012. And it didn't just win, it crushed the competition. It was so much better than anything that had come before. This was the moment everyone realized deep learning wasn't just some academic theory anymore. It was real, it was powerful, and it worked. Okay, so that 2012 breakthrough is what brings us to today, to the world of generative AI and everything else. But just like before, as the power has exploded, we're starting to see new paradoxes and run into a whole new set of walls. So let's be really clear about what these things, these large language models actually are. On one hand, they're amazing pattern matchers. They are prediction engines, brilliant at guessing the next word in a sentence based on all the text they've seen. But here's what they are not. They are not conscious. They are not thinking or understanding in the way a human does. It can feel like you're talking to something intelligent for sure, but it's an incredibly convincing simulation, not genuine thought. And wouldn't you know it, that historical cycle is happening all over again. We're hitting new limits. The cost to train these models is just astronomical. We're talking insane amounts of computing power. Plus, we might actually be running out of good data from the internet to feed them. And on top of that, the internet itself is changing. The data commons is shrinking as more and more websites are blocking AIs from reading their content. And this all leads us to our final section, and honestly, maybe the most important one, the human cost of code. Because as AI gets more and more powerful, the biggest problems aren't about technology anymore. They're about us. They're about ethics and what it means to be human. I want to share this quote with you. It comes from a source in Haitian Creole, and it introduces this really powerful idea of an AI precariat. It's talking about a class of people who, because of automation, lose more than just their income. They lose their sense of identity, their purpose. And it's so important that we look at sources like this from different languages and cultures because it's a stark reminder that the impact of AI isn't some abstract Silicon Valley debate. It's personal, it's cultural, and it's felt very differently all over the world. Now, if you look at the numbers, the story gets even more complicated. The World Economic Forum thinks that, yeah, AI will displace a ton of jobs, maybe 92 million, but it's also projected to create even more new ones, like 170 million. So the real takeaway here isn't just, oh no, the robots are taking our jobs. It's about a massive, messy transformation. The entire job market is shifting under our feet, and that's going to demand totally new skills and, frankly, create a lot of new challenges for people. So that brings us back to where we started. The history of AI has always been this cycle, right? Human ambition slamming up against technical limits. But as we get better and better at solving the technical problems, we're facing a totally new kind of limit. So I'll leave you with this question. As AI's power just continues to grow, is the most important barrier we face no longer about tech, but about us, about our own ethics, our own wisdom, and how we choose to use what we've built?